Good morning, my dear friends. In the previous tutorial video, we have discussed about percentile rank, and I have told you guys that in the upcoming tutorial videos, we will discuss about various other features, that is interquartile range, what is quartile, what is z-score, the box plot, the whisker plots, etc. So this will be the last tutorial video of our section probability and statistics that is used in machine learning. So please pay attention to this particular video. In this particular video, we will discuss about other important features such as interquartile range. In the previous tutorial video, I have showed you a diagram thing. Like one second, is the diagram. Yes, in the previous tutorial video I have shown you a graph. Okay, I have shown you a graph regarding a bell-shaped curve where I have discussed about the various percentile, the median, etc. So what is interquartile range? The first quartile is the 25th percentile of a data set. The second quartile, just keep a note of all these things that I'm telling you, because this is actually it will be really beneficial for you, is the 50th percentile. And friends, tell me, what is 50th percentile? 50th percentile is also termed as median. You are absolutely right. The third quartile is the 75th percentile. As you can see, it is increasing by 25, because what actually happens, 1 by 25 percentage of 100 is nothing but 1 by 4. Exactly. 25% of 100 is nothing but 4. So therefore the first quartile is nothing but 4. So 1/4 of 100 is also termed as 25%. Okay. The IQR, which is also termed as interquartile range, means the difference between 75th and 25th observations. Using the formula, okay, the IQR equal to Q3 minus Q1. So this is what is actually happening. So now I will discuss about another important concept that is termed as z-score. So what does z-score actually mean? The z-score for these dogs are barking here. The z-score for a particular data value, please don't mind the dogs, the street dogs, okay, represents how many standard deviations the data value lies above or below the mean. So this is termed as a z-score. So z-score mathematical formula can be represented by just z. So this is the particular formula that I have. This is the curve that I was talking about. Like 25%, this is the 25th percentile. This is the 50th percentile, the 75th percentile, which is also termed as the third and first quartile. And as I have discussed, what is nothing but interquartile range. Interquartile range is nothing but the difference of third quartile minus first quartile is termed as the interquartile range. And what is z-score? Z-score for a particular data value represents how many standard deviations the data value lies above or below the mean. So x minus x bar by s. This is termed as z-score. For example, if z-score is positive, it means that the value is above the average. Suppose the z-score is 24,000. Okay, this is the x, 24,000. X bar is nothing but 32,540. and suppose S is 7201, so it comes out to be minus 1.2. Okay, and since it's coming negative, it means that the income of that particular applicant is less than, lies 1.2 standard deviations below the mean. This is what Z score actually means. Okay, so now we'll discuss one important concept that will be very much required when you are very much will be required by you guys when you will be doing data science projects, that is univariate descriptive statistics. So what does univariate actually mean? Different ways, just keep a note of all these things that I am writing in the notepad, because it would be very much beneficial for you guys when you will revise the concepts, because it's very important to keep on revising the concepts again and again after 15 days or after 1 month, because it helps you to engrave the concepts in your mind. You can and then you can use it in your projects, and this will be very much beneficial for you guys. Okay, and plus you can, because in the interview sections they ask about certain technical concepts related to the statistics and probability. At that particular time, these information that I have listed out will very much help you. The different ways you can describe patterns found in univariate data include central tendency, which I have already taught you guys. Central tendency में क्या आता है? Central tendency में it comes mean, median, mode, median mode, dispersion. Dispersion में क्या आता है? Dispersion में range, variance, max, min, quantiles and standard deviations. Okay, so univariate descriptive statistics is nothing but describe various patterns found in univariate data. For example, I will just show the picture. Like you can say that out of 40% is about 50% people is married, 10% are single, I am single, and the others are not married. So how much this is? This is nothing but 100 minus 50 plus 10, that is 40%. It can be shown in the help of a bar chart, where the y-axis describes the frequency and this is the marital status, and by the bar graph you can very well see. So this is nothing but a univariate analysis has been done. Okay, now we'll discuss about bivariate analysis. But what is bi? Bi means two. Bivariate descriptive statistics. The bivariate analysis involves the analysis of two variables. That is very important. This is analysis of one variable, this one, and this is analysis of two variables for the purpose of determining the empirical relationship, or you can say for the empirical relationship between them. Okay, the various plots that we can found for the bivariate descriptive statistics are the scatter plot, the box plot, the violin plot, etc. So we'll discuss one by one. So what is first one is scatter plot. What is scatter plots? Scatter plots is nothing but you can say the simplest way to visualize the relationship between two quantitative variables x and y. Okay, for two continuous variables, a scatter plot is a common graph. Okay, so scatter plot will be a common graph for two continuous variables. Suppose each xy point is graphed on a Cartesian plane with the x-axis on the horizontal, y-axis on the vertical. Scatter plots को correlation plots भी बोलते हैं because they show how two variables are correlated. How two variables, or what relation does two variables share with each other is explained by scatter plots. So how two variables are correlated is shown by scatter plots. Now we'll discuss what is correlation. Correlation is a mathematical term that you must be aware of. This is nothing but a statistic intended to quantify the strength of the relationship. It just qualifies or it describes the strength of the relationship between two variables. The correlation coefficient is nothing but R, quantifies the strength and direction of the linear relationship between two quantitative variables. Okay, the formula comes out to be this: sigma x minus x bar y minus y bar by n minus 1 sx xy. What is sx xy? Sx xy represents the standard deviation of the x variable and standard deviation of the y variable, and this r always comes out to be minus 1. This is nothing but the range of r, comes out to be r. This is the range. It should lie between minus 1 to 1. Okay, if r is positive, so this is the section r is positive, this is termed as positively correlated, and when it is this is negatively correlated. So I will just show you some pictures that would help you to visualize this particular thing. So this is nothing but a positive correlation. What does that mean? R is greater than that of 0 but less than 1. This is negative correlation. R is greater than minus 1 but less than 0. And no correlation. No correlation means R equal to 0. There is no particular relation between x and y. What are these? These are termed as scatter plots because the points are scattered around. So this is termed as scatter plots. So now we'll discuss the last and the most important concept about plots in the bivariate analysis is termed as box plots. Box plots, what is box plots? A box plot is also a box and a whisker plot, and it's used to as you can say picture the distribution of values. It just shows the distribution of the values, the whole picture of it. When one variable is categorical, you can say, and the other continuous, a box plot is commonly used. When you use a box plot, you divide the data values into 4 parts. The 4 parts are also called quantiles. You start by finding the median or middle value. The median, what it does, it splits the data values into 2 halves. Finding the median of each half splits the data value into 4 parts, which is also termed as quartiles. I will just help you because it's very much difficult to picturize it. This is nothing but what is exactly happening. This is termed as whiskers, and this is the maximum value, this is the minimum value, this is the median, this is the interquartile range. What is interquartile range? The interquartile range is nothing but the difference of the third quartile minus first quartile. What is third quartile? Third quartile is nothing but the 75th percentile. The first quartile is nothing but the 25th percentile, and the difference is the interquartile range. This is the whiskers. The whiskers then point to the largest and the smallest values in the data. Okay, the left whisker extends down to the minimum value, which is not an outlier. Okay, then the right whisker extends up to the maximum value, which is not an outlier. When the left whisker is longer than the right whisker, then the distribution is left skewed, and vice versa. Okay, when the whiskers are equal in length, this is also termed as symmetric. Yes, so with this particular topic, we have fully covered the statistics that is very much beneficial in machine learning. We have discussed all the various concepts. Now it's your time to dive deep into machine learning using statistics. Don't need to understand statistics further. In the process of learning, in the process of doing various case studies, in the process of doing various machine learning process, you will discover more and more, because there is obviously no end to learning. But at the least, I will like to conclude by saying that all the basic concepts of probability and statistics are a must for anyone interested in machine learning, because if you want to do machine learning without probability and statistics, I feel you cannot do, because machine learning is all about how you quantize and extract information from the data. And if you want to extract information from the data, it's very important to know about how the data is being distributed, how the various features and attributes of the data are being distributed against certain quantities. And the study of understanding the distribution of the data is only termed as probability and statistics. So in this tutorial videos, I have covered briefly some of the essential concepts that are mostly used in machine learning. And I really hope that you have enjoyed this particular tutorial videos and learned something very much new and useful that you will definitely cover in your future endeavors. So happy studying, keep enjoying, and just enjoy what you are learning, and keep working on some amazing projects. So goodbye.